Husky here. Hope you're having a great day. Today we're going to talk about just a little bit of a review for the 4.1 to 4.3 quiz, which you guys have coming up next class. First thing I want to do is just go through what's going to be on the quiz. So conversion between angle measures, so going from degrees, minutes, and seconds, that's the degrees, minutes, and seconds thing, to decimal degrees, that's where you just have a decimal, and radians, of course, which is, remember, 1 radian is the length that 1 radius would wrap around the outside of the circle. Arc length, which we have the two formulas for, or you can think about the percentage of the circle. Dimensional analysis, which is where we're converting units using the box method, kind of. SOHCAHTOA and CHOCHOCAL, and then the unit circle, which is what we've been focusing on the last few days. Radians and degrees, positive and negative, and extended values. That's where, if you go up, if it's positive, you go down, if it's negative. If it's more than 2 pi, like 17 pi over 3, something like that, you have to know how you get to that point. And then all 6 trig functions. So sine, cosine, tangent, secant, cosecant, and cotangent of those normal 16 values on the circle. Terminal ray of an angle is something that we haven't talked about. And so we're going to go over that together today. So, and then at the end, I'm going to show you some neat tricks that kind of relate to this stuff. I wanted to do them while I was there, but unfortunately we didn't have time. So at the end of the video today, if you're done with it and you think you've got it, don't watch them, but I've got some kind of cool tricks that we can show you. So let's jump in. So first we're going to do a little conversion here. So we've got 23 pi over 15. We're going to convert that to degrees and also to degree, minutes, and seconds. So 23 pi over 15 must be radians because there are no units there. So 23 pi over 15, put it into the box. So we want to do a 180 and a pi. I want the radians to cancel, so the pi goes on the bottom, 180 degrees on the top. I'm going to rewrite that as not 123 pi, just 23 pi over 15 times 180 over pi. The pi's cancel. 180 divided by 15, that value, you might have to do it in pieces, but if I divide them both by, let's say 3, so that'd be 60 over 5, which I believe is 12. So this is 23, oops, keep doing that. 23 times 12. You can grab a calculator at any point here, but let's see if I grab it now. So 180 divided by 15, double check that that's 12, and it is, and multiply by 23, I get 276 degrees. Now, that value, unfortunately, is not going to be a good degree, minutes, seconds problem because there's no decimal after it. So let's actually do, for converting degree, minutes, seconds, let's do 276.7125 degrees. And let's see if that's going to work out a little bit better. So what we're going to do is put that into our box. Oh, not yet. So the 276, we know we have 276 degrees. We need to know how many minutes and how many seconds. So we'll start with the 0.7125 degrees. And we know that 1 degree, put that on the bottom because we want it to cancel, is worth 60 minutes. So let's see how many minutes we have. So we do 0.7125, multiply by 60, and I get 42.75. So that means we have 42 minutes, excuse me. So we took that right there, and then we have 0.75 minutes left. 1 minute is 60 seconds. So that's 3/4 of 60. I think I know what that is. Let's check anyway. 0.75 times 60 is 45. So you got 45 minutes. That's how you convert from degrees to degrees, minutes, seconds. Change the decimal to minutes, and then take the decimal of the minutes, change those to seconds. Cool. Okay, so doing a, and remember going, man, I don't have a problem with this. So going from degrees, minutes, seconds back to degrees, remember that you have to take each piece and convert it to degrees, and you add all 3 pieces together. So you might want to go back in your notes for a problem like that. So Carly and Elena are on a Ferris wheel. The wheel has a radius of 45 feet. Let's make our feet here. There we go. Okay, there are Carly and Elena. Yay. Okay. All right. And it says that the wheel rotates through 84 degrees. How far did the girls travel? So 84 is almost 90. That's probably a little too small. But the question is, how far did the girls travel? So how far is that arc length? What's the length of that arc? So we have 84 pieces out of 360. We're multiplied by the circumference of the entire circle, because this is going to give us the percentage of the circumference we want. So we have 2 pi times 45. Grab our calculator and just punch that in. So 84 out of 360. I get 0.233 multiplied by 2 pi. Multiply that by 45, and I get 65.97 feet. So in 84 degrees, which is somewhere between 1 and 2 radians, makes sense to me, that you're going to end up going somewhere between 45 and 90, and 65.97 feet. Cool. Might want to grab a calculator and actually do these calculations along with me. Not a bad idea. And at any time, if you want to try these problems on your own, go ahead and pause the video, and then you can bring it back and we'll do them together. But I'm just going to kind of keep plowing through them. All right, dimensional analysis. So Ryan Tamte claims he can bag groceries at 32 items per minute. If an average of 7 items fit in a bag and 12 bags fit in a car, how many cars does Ryan fill in his 8-hour shift? All right, well, let's see. I'm going to start with our 32 items per minute. We want to end up with cars per shift, I guess. So we want cars per shift. And we have all of the conversion factors that we need in here. So 37 items per minute. Let's take care of getting the time to a shift first. So we know 8 hours are in a shift. So we got to get to hours first. There's 60 minutes in 1 hour. So the minutes go away. And then 8 hours in 1 shift. So the hours go away. So now we have shift on the bottom, which is what we want. So we've got that all taken care of. Now we got to get items into cars. So 32 items, and we have 7 items in 1 bag. So items cancels. And then 12 bags in 1 car. Bags are gone. So now we have cars per shift. Now we should multiply straight across the top. So I'm going to grab my calculator. 32 times 60 times 8. I get 15360. Divided by 15 times 12, 7 times 12. So 15 times 7 times 12, I get 1260. So 15,360 divided by 1260, I get 12.19 cars that he fills in an 8-hour shift. That's all there is. Let's try another one. A merry-go-round has a radius of 20 feet. There we go. And completes the revolution in 12 seconds. So 1 revolution is 12 seconds. What is the speed of the outside of the merry-go-round in meters per hour? So I want meters on top. I want hours on the bottom. So I'm going to put seconds on the bottom because that's where I want the time to be. So 1 revolution is 12 seconds. Now we're going to change to radians. So 1 revolution is 2 pi radians. And 1 radian in this case is going to be equal to the length of the radius. That's 20 feet. Now the annoying thing here, so we've got revolutions gone, we've got our radians gone. We need to change into meters. Well, I don't know how many feet are in a meter, but I've got a unit conversion here of 2.54 inches to a centimeter. So I got to take my feet to inches. And then 1 inch is 2.5. Oh, I mixed this up. I am so sorry. This should be inches, and this should be centimeters. My bad. Did that too late last night. So 2.5 centimeters to 1 inch, and there are 100 centimeters to 1 meter. So we've got our meters. Centimeters are gone. Inches are gone. Feet are gone. Radians are gone, but I didn't write them. So we now have meters, which is what we want, and then we got to get the bottom to hours. So 60 seconds in 1 minute. Seconds are gone. And then 60 minutes in 1 hour. Minutes are gone. So now I think we have, let's see, meters per hour, which is what we wanted. So we multiply all the way across the top. So I'm going to leave the pi alone. So we got 2 times 20 times 12 times 2.54 gives me 1219.2 pi. And on the bottom, 12 times 100, that's 1200. So it looks like if we do, this is, oh no, we got the pi. I was going to say this is pretty slow. 1 revolution every 12 seconds? I don't know. Let's see. So we got 1219 pi divided by 1200. 1219.2, excuse me. Gives me 3.1918. That seems very slow. You know why? Because I think I forgot this extra 60. I think that's why. So I'm going to get rid of these. Try that again. So 2 times 20 times 12 times 2.54 times 60, and then 60 again. Ah, that looks better. So upstairs, we have 4389120 pi. And on the bottom, I think we were actually right. That was 1200. So if we do this times pi and divide by 1200, that looks better. That is 11490 meters per hour, 0.68. Cool. All right, moving on. So we're looking for the 6 trig functions of the given reference angle. So we have the 6 trig functions of theta. So sine theta, cosine theta, tan theta, secant theta, cosecant theta, and cotangent theta. So we use SOHCAHTOA and SHOCHOKAU here. We need to find that last side first, so it's called x. So we got x squared plus root 13 squared equals 7 squared. So that's x squared plus 13 equals 49. Subtract, we got x squared equals 36. Yeah, that's nice. X is 6. So sine, opposite over hypotenuse, 6/7. Cosine, adjacent over hypotenuse, root 13 over 6. Tangent, opposite over adjacent, 6 over root 13. Now, we don't like the root in the bottom. For the quiz, I'm okay with you leaving the root in the bottom because it shows you know the function, but really we should multiply by root 13 over root 13. So that is 6 root 13 over 13. Secant is hypotenuse over adjacent. That's 7 over root 13. Rationalize that. It'll be 7 root 13 over 13. Cosecant is hypotenuse over opposite, 7, 6. We can leave that alone. Cotangent, adjacent over opposite, root 13 over 6 can also be left alone. That's all there is to it. All right, if theta is an acute angle and tangent is 3/2, we're going to find the other 5 trig functions of theta. So I'm going to make a triangle here. I'm actually going to try to make it relatively correct. So here's theta. Opposite over adjacent is 3 over 2. Of course, I didn't do it right. The 3 should be longer. And so we have to find the other 5 trig functions. So we have to find this third side. And this third side is going to be, let's see, so x squared would be 4 plus 9. So x is root 13. That's really the only difference with this problem is you have to find that third side first. So sine, opposite over hypotenuse, 3 over root 13, which would rationalize to 3 root 13 over 13. Cosine of theta, adjacent over hypotenuse, is 2 over root 13, which is 2 root 13 over 13. Tangent, we already have, it's 3/2, opposite over adjacent. Secant is hypotenuse over adjacent, that's root 13 over 2. Cosecant is, let's see, show hypotenuse over opposite, that's root 13 over 3. And cotangent is going to be adjacent over opposite, which is 2/3. And that's all there is to that problem. Not too bad. All right, unit circle stuff. So there are 10 unit circle problems on your quiz, and they're a mix of sine, cosine, tangent, positive, negative values. Some of them are extended, so we're going to try to catch them all here. So cosine of 5 pi over 6, I think about that. 5 pi over 6 is 1, 2, 3, 4. 5 is right there. Cosine there is the long value, and it's negative because it's on the left, so it's negative root 3 over 2. Sine of 5 pi over 4, 1, 3, 5. That's this guy down here. Sine is going to be negative there, negative root 2 over 2, because it's one of the corners. Sine of negative 4 pi over 3. Negative goes down. That's 8 pi over 6. 1, 2, 3, 4, 5, 6, 7, 8 is right up here. Sine is the y value, so it's the long one here. It's going to be root 3 over 2. Tangent of negative 2 pi. Well, negative 2 pi doesn't matter which direction you go, but that's going to get me right back to here. That's 0. Tangent of 7 pi over 4. 1, 3, 5, 7. Right there. Tangent there is going to be some kind of 1, and because sine and cosine have different signs, it's negative 1. 19 pi over 6. All right, a couple ways to do this. One is we can just keep counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, puts us right there. Or you can say, well, 12 pi over 6 is all the way around, and then left over you have 7 pi over 6, which brings us there. Those are coterminal angles. They both end you at the same spot, and that's all that matters for finding tangent. Tangent there will be the short value, and it's positive root 3 over 3. Secant of 11 pi over 6. So 11 pi over 6 is almost all the way around right there. Secant uses the normal tangent lines. It's the shortest value of secant that isn't 1, so that's going to be 2 root 3 over 3. And it's positive because we're on the right side of the circle, and that deals with cosine. This is 1 over cosine, so positive because we're on the right. Cotangent of negative pi over 6. Negative pi over 6 puts us in the same spot. Cotangent there is going to use the cotangent lines. It's the long value for cotangent, that is root 3. And it's going to be negative because sine and cosine had different signs there. Cosecant of negative 5 pi over 4, 1, 3, 5, right there. Cosecant uses the cotangent lines. Cosecant deals with sine, so it'll be positive here because it's above the x-axis. And so it'll be positive root 2. If you can do those 9, you're going to be all set, I believe, for the quiz coming up. All right, so the terminal ray of an angle. So for the terminal ray of an angle, sometimes what you'll be told is something like the terminal ray of theta passes through a certain point. So passes through, let's say 4, negative 3, let's say. So for a problem like this, I always make a picture. So I'm going to find out where 4, negative 3 is. 1, 2, 3, 4, negative 1, 2, 3, right there. Okay. So the terminal ray of an angle, that means that the ray passes through there. So what they're saying is that you have a theta that starts at standard position, and it goes all the way around to that point. And then what they might ask for is find the sine and cosine. Okay, so find sine of theta and cosine of theta. Okay, and you could find tangent, cotangent, secant, cosecant, all those things as well. But really all you have to do is you have to make a reference triangle that makes this happen. And the key is that you need to make sure that you have the sine and cosine in the correct spots. So what I would do for this is I would make this into a triangle. Now the important thing is where you put theta. Because some people like to make the triangle here and put theta there. That won't work because you need to make sure that the cosine deals with the x value. So you need your theta to be adjacent to the x-axis. That's always the way I think about it, is theta needs to be adjacent to the x-axis. If it's not adjacent to the x-axis, you're going to get a wrong answer. So if we break that triangle out, it looks like this. So theta adjacent to the x-axis, there it is. So 4, negative 3 is the coordinate point there. That means this length is 4, and this guy is negative 3. You could make it just a 3 and then figure out the signs later. I think it's easier to do it this way. So we need to find the hypotenuse. So a squared plus b squared, 16 plus 9 is 25. Square root of 25 is 5. So we have a 3, 4, 5 right triangle. So to find sine of theta is going to be opposite over hypotenuse, negative 3/5. And cosine of theta would be 4/5. Now really, if you think about this, what we're doing is the length of this is 5. If we draw our unit circle, it maybe go like right there. What you're doing is you're taking this coordinate and you're reducing it down to where it's going to be in the unit circle. So dividing by 5 makes that hypotenuse 1. You don't have to know that. It's just if you make the triangle, it's kind of interesting to see that like what you're doing is you're taking a big circle that would be all the way out here, and you're reducing it down to a unit circle by dividing by the hypotenuse, because that'll make the radius be 1. Now let's have you guys try a few. What do we got here? I got terminal ray passes through negative 5 root 2. Okay, and for all these, you're going to be find sine and cosine. So sine of theta and cosine of theta. And you know what? If you want to, find tan and secant, cosecant, cotangent. You can do that as well. It's just going to be using SOHCAHTOA and SHOTOKAU after you get the triangle. So let's do negative 5 root 2. Let's do 0, negative 3, and 7, 0. So if you want to give these a shot, you can kind of just draw a picture yourself and see if you can figure it out. All right, so the first one is very similar to the one we just did. So if I go to negative 5 root 2, I'm going to need over here. So here, let's say it's right here. Okay, negative 5, comma, root 2. So I'm going to draw my triangle. There we go. And I want theta adjacent to the x-axis, always. So we have this triangle. Here's theta. Here's negative 5. Here's root 2. Got to find the hypotenuse, so that's 2 plus 25. So I guess this is root 27. We could reduce that because that would be 3 root 3 right there. And so, but let's just use it as root 27. So cosine theta adjacent over hypotenuse, negative 5 over root 27. If we rationalize, that's negative 5 root 27 over 27. And then for sine of theta is going to be opposite of hypotenuse. That's root 2 over root 27, multiplied by root 27 over root 27. Gives us root 54 over 27. And again, you could rationalize this. You could take out a 9. I guess it would be, 3 root 6? But you don't have to do that. So for these, I wanted to make sure to include these because they're a little bit weird. 0, negative 3 is right here. And if we just think about it, sorry, I should draw graph 1, 2, 3 right there. So if that is the terminal ray of an angle, it's at the bottom of the circle. And the cosine value there is 0. And the sine value there is negative 1. Okay. So these that are on the axes are a little bit different, but you just have to think, well, that means I'm at the bottom of the circle, because if the terminal ray of the angle is there, it doesn't matter what size the circle is, whether it's a unit circle or whether it's a 3 or 7 or whatever, the angle puts you at the bottom of the circle. You're at 3 pi over 2. 7, 0, same idea. 7, 0 puts you out to the right. So cosine is going to be 1, and sine is going to be 0. So just kind of a different way of thinking about trig functions. Not too bad, though. I have some problems for you if you want to give them a shot. I forgot I had these here. So if you want to try these out, go ahead, and then we'll try them together. All right, 3, 5. Here's 3, 5. So that gives us a 3, 4, 5 right triangle. 3 here, 5 here. This is, sorry. No, it doesn't, because the 5 is the y-coordinate. So this would be 25 and 9 is 34, it'd be root 34. And here's our theta. We want it adjacent to the x-axis. So cosine would be 3 over root 34, which is 3 root 34 over 34. Sine would be 5 over root 34, which is 5 root 34 over 34. Negative 8, 4. Let's say it's like here. There's our triangle. Theta adjacent to the x-axis. So, let's see, we have 4, negative 8, here's theta. So this would be root 16 and 64, that would be square root of 80. Could do some simplifying there, but I'm not going to. Cosine would be negative 8 over root 80, which is negative 8 root 80 over 80. You could reduce that to 1/10, I suppose, so negative root 80 over 10. The reduction I'm not too concerned about, as long as you're getting the triangles. 5, negative root 3, somewhere over here. Get our theta adjacent to the x-axis. So we have a triangle that looks like this. This is 5, this is negative root 3, this is theta. So cosine theta will be 5, let's see, so 25 and 9 are, no, sorry, 25 and 3, 28. So this would be root 28. So cosine theta would be adjacent 5 over root 28. Which is 5 root 28 over 28. And sine theta would be negative root 3 over root 28. Which should reduce to, let's see, 3 times 28, 90 minus 6, 84. So negative root 84 divided by 28. Cool. So there's a couple of problems on your homework assignment for tonight that deal with these terminal rays. I want to make sure that you saw some of them before you jumped into it. All right, so now we're going to show some neat tricks. If you feel like you are happy with what you know about unit circle, you can definitely stop here. Just kind of want to go through some of the stuff that some people have said is useful. So first, the ninja and the hourglass have to do with finding radian values. So you may have noticed, like when you do the unit circle, the pi over 6s, there are only 4 of them on the circle, and they kind of make a ninja. So if you make it like this, you can kind of see like it's a guy wearing a mask. Okay, so this is pi over 6. This would be 5 pi over 6. This is 7 pi over 6. This is 11 pi over 6. So I always got to remember that at those points, like cosine is some kind of root 3 over 2. Sine is some kind of 1/2. And then you can extend this, right? Like that means secant would be 2 root 3 over 3. Cosecant would be 2. tangent is root 3 over 3 there, and cotangent is root 3. And then you have to figure out whether they're positive or negative depending on which quadrant you're in, which we're going to talk about in the next slide. So you got the ninja, and then the hourglass also does the same thing. The hourglass is where you have the pi over 3's. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And all of these, so these kind of flip everything around, right? Cosine is 1/2, or negative 1/2 if you're on the left. Sine is root 3 over 2. Tangent is root 3. So then secant is 2. Cosecant is 2 root 3 over 3. And cotangent is root 3 over 3. So just kind of the ninja and the hourglass, kind of two things that I think about when I'm doing the circle. When you do lots and lots and lots of these, you start recognizing these patterns. It's just kind of cool. All right, next up, all students take calculus. So this one has to do with where things are positive and where things are negative. Because like, if you have like a cosecant of, let's say, like 5 pi over 3. So 5 pi over 3 is this value right here, and it's like, okay, I know it's the cotangent line because it's a co-function, and we extend it out, it's the length of this line. That looks short, so it's 2 root 3 over 3, but then it's like, gosh, is it positive or negative? I'm not sure. The way I remember that is that it's 1 over sine, and sine there is negative, so it's going to have to be a negative value. There's a way to remember when sine and cosine and tangent are positive, and it's all students take calculus. So it goes in the order of just how you would think about the circle going around in a counterclockwise fashion. All means that sine, cosine, and tangent are all positive there, because you have a positive sine and positive cosine, so when you divide them, tangent will also be positive. In the second quadrant, you have a negative cosine value and a positive sine value. So sine is the only one that's positive there, which means when you divide sine over cosine, it will also give you a negative value for tangent. So everything in the first quadrant positive. Second quadrant, sine is the only one that's positive. In the third quadrant, I think that tangent is the only one that's positive, because we would have a negative sine and a negative cosine. So when you divide them, tangent is the only one that's positive. In the last quadrant, we're on the right side of the axes, so we're going to have a positive cosine, but then we're going to have a negative sine, so that'll make a negative tangent. So all students take calculus, and unfortunately, because of the cosecant and secant, the letters don't match up, but if you remember that cosecant is 1 over sine, you'll be able to know on the bottom all of those will be negative, and for secant, that's associated with cosine, so on the left side, the secant values will all be negative. Just kind of a way to remember positives and negatives.